This is the review video for the study guide for Unit 1. And here we go. You'll notice that the formulas are at the top of the page. It's going to be the same thing as on the test. So let's get into it. Given the sequence -6, 3, 12, what is U5? So this is a arithmetic sequence that you're adding by 9 each time. So if we take 12 and add 9, and add 9 again, that's the fifth sequence. So that would be 30. Is it arithmetic or geometric? It is arithmetic because you're adding by 9. There's a common difference because it's arithmetic. And the common difference is 9. What is the recursive definition? That's the only formula piece that's not on the test. That's not given to you on the test. So we have u sub n is equal to u sub n minus 1 plus 9, where n is greater than or equal to 2, and u sub 1 is equal to, I'm not sure. Let's check it out. -6. Okay, please don't get the recursive definition and the explicit definition switched up. Explicit definition. This is the case where you're going to write the explicit formula down and put the information you do know in it. But since you don't know all of it, you can't solve for a term. So you have u sub n is equal to the first term, which is -6, plus 9 times n minus 1. That's as far as you can go because you're not told what term to find. That comes in the next piece. What's the 20th term? So we're going to use our definition that was right above, but now we can put in for n 20. So we do 9 times 19 minus 6 gives us 165. Partial sum, again, of an arithmetic sequence. 33 is going to be our k value, so we have 33 times -6 plus 33 times 33 minus 1 divided by 2 times -6, times 9. So I'll do 33 times 32, divided that by 2, times that by 9, plus 33 times -6. Gives me a grand total of 4,554. Again, this is all I would need to see on the test. You set up the formula, you find the answer. Everything else is a calculator issue. Number 2. This sequence, you're multiplying by -2 each time, so it is a geometric sequence. If I take -8, multiply it by -2, that would be the fourth, by again, the fifth, again, that would be the sixth, which would be 64. We already said it was geometric, which means it has a common ratio, and you're multiplying by -2. Cursive definition, u sub n is equal to u sub n minus 1. Oops, let's change that up. We're multiplying by -2, so we're going to put it in front. And we have our statement. Where n is greater than or equal to 2, u sub 1 is equal to -2. Explicit definition of a geometric sequence. We have u sub n is equal to the first term, which is -2, times the common ratio is also -2 to the n minus 1 power. 13th term. U sub n is equal to -2 times -2 to the 13th minus 1 power. Now it's important for this one, you should put this in parentheses for when you actually do it, because if you do it without parentheses in the calculator, it's going to give you the wrong thing. All right, so we're going to put 2 to the 12th power times -2 gives me -8192. Now for the 20th partial sum, we're going to have u sub 1, which is -2, 1 minus -2 to the 20th power, divided by 1 minus -2. Again, put this in parentheses because it's going to help you out for later. Just going to be nicer. So we have 1 minus oops, minus -2 to the 20th power divided by 3 times -2 gives me 6,99050. Okay, moving on to number 3. Excuse me. You go 28 to 35 to 42. We're adding by 7 each time, so we're just going to write the recursive definition. U sub n is equal to u sub n minus 1 plus 7, where n is greater than or equal to 2, and u sub 1 is equal to 28. Again, most students will get the recursive and the explicit definition flipped, so please don't do that. You're given the explicit definition, you're not given the recursive. That's kind of one way to remember it. Explicit definition would be u sub n is equal to, first term is 28 plus 7 times n minus 1. Then we're going to find the 11th term using the same formula. So 28 plus 7 times 11 minus 1. 7 times 10 plus 28 is 98. 20th partial sum of k would be the 20 times 28 plus 20 times 20 minus 1 divided by 2 times the common difference, which is 7. So 20 times 19 divided by 2 times 7 plus 20 times 28. 1890. All right. And number 4, we have a sequence. We are multiplying by 2 each time. So u sub n is equal to 2 times u sub n minus 1, where n is greater than or equal to 2. U sub 1 is equal to 1 over 16. All right, explicit definition, we have u sub n is equal to, the first term is 1 over 16 times 2 to the n minus 1 power. 23rd term, 1 over 16 times 2 to the 23, 23 minus 1 power. So 2 to the 22nd power times 1 over 16 is 262,144. And then the partial sum of this, 1 over 16, 1 minus 2 to the 18th power over 1 minus 2. So 1 minus 2 to the 18th divided by -1 times 1 over 16. I'm going to make that into a fraction. Gives me 262,143 over 16. There we go. So far, so good. All right. Now we're getting to summation notations. Okay. So in this problem, number 5, we're going from 1 to 5, which means we're only finding 5 terms. So there's no use in trying to use a formula because you're only finding 5 terms. By the time you find the third term, you can just find the last 2. You don't need to use a formula. So put 1 in for n. So 1 plus 1 is 2, and 2 squared is 4. We put 2. 2 plus 1 is 3, and 3 squared is 9. And 3 in for that, you get 4. 4 squared is 16. Then we get 25. We get 36. So we're doing all the perfect squares, starting from 4. So we have 4 plus 9 plus 16 plus 25 plus 36. Gives me a grand total of 90. That is the sum of all the terms. Again, we're starting at 1. We're ending at 5. So putting in 1 for n, we have 1 squared is 1 times 3 is 3. 2 squared is 4 times 3 is 12. 3 squared is 9 times 3 is 27. 4 squared is 16 times 3 is 48. And 5 squared is 25 times 3 is 75. Again, we only had to find 5 terms, so it makes sense to just find the terms themselves and then add them up for a grand total of 165. And number 7, though, there's no way I'm finding 135 terms. So what we're going to do instead is we're going to find the first 3 to figure out what the sequence looks like, and then use a formula based on what the sequence is to find the sum. So I've put 1 in for n. 3 times 1 is 3, minus 1 is 2. Put 2 in for n. 2 times 3 is 6, minus 1 is 5. Put 3 in for n. 3 times 3 is 9, minus 1 is 8. So that's 3 terms. Now I can tell you what the sequence is. It's an arithmetic sequence that increases by 3 each time. All right. So now I can put that information. So I know u sub 1, which is 2. I know my common difference, which is 3. And I know my k value for this problem, which is going to be 135. So with that information, I can put it into the partial sum formula for arithmetic sequence. I'm going to have 135 times 2 plus 135 times 135 minus 1 divided by 2 times 3. So 135 times 134 divided by 2 times 3 plus 2 times 135 gives me 27405. Now, using the formula was much better than trying to find 135 terms and adding them all up. So please keep that in mind when you see these types of problems and they have a very large k value. All right. Some word problems. At the start of the zombie apocalypse, there you go, which is month 1, the population of Atlanta was 472,500. Started month 2, it was that. Month 3, it was that. Okay. If this pattern continues, what would the approximate population be at the start of month 12? Okay. So one thing we know right away is we're not looking for the total population. We're looking for a term, which means we're using the explicit formula. All right, next we've got to figure out what is going on with this. I'm going to take a guess, a wild guess, that 472,500 times 1/2 will give me my population for month 2. So I'm going to be multiplying by 1/2, which is a geometric sequence. All right, so I have to find the explicit for that. So I have u sub n is equal to the first term, which is 472,500 times 1/2 to the 12th minus 1 power. So 0.5 to the 11 times 472,500 gives me 230 people. It says 0.71, but you can't have 0.71 of a person, so we have to round down. Number 9. Car is valued at $18,500 when it is bought new. Every year thereafter, it loses $2,000 in value. Given the scenario, write the recursive definition. So the recursive definition is going to be u sub n is equal to u sub n minus 1 minus 2,000, where n is less than or equal to, or greater than or equal to, 2, and u sub 1 is equal to the total value of the car when it started, 18,500. Now write the explicit definition. So again, we're not finding a term, we're just putting the values into the explicit formula that we do know. We know u sub 1, 18,500, plus the common difference, which is actually going to be minus then n minus 1, because it is an arithmetic sequence. All right, number 10. On the first day of school, Mr. Blecker had his students solve 10 equations, and the next day he had the students solve 12 equations, and the third day they were solving 14 equations. How many equations do Mr. Blecker's students solve in all during the first 30 days of school? So the key part of that is in all. That means you're finding the sum of all the equations they solved all the days that they were in the school for the first 30. All right, because they're solving 2 more equations per day than they did the day before, it is an arithmetic sequence with a common difference of 2. So your k value is going to be 30. Your first term is 10 plus 30 times 30 minus 1 divided by 2 times 2. So we have 30 times 29 divided by 2 times 2 plus 30 times 10. So altogether, in 30 days, they've solved 1,170 equations. Okay? And again, it's the in all during the first 30 days. It doesn't say on the 30th day of school how many equations did they solve. That would be the explicit then. Number 11. Miss Ward opens a new bank account, deposits $100. Every year she deposits the same amount that she has in her account at that time. She never uses her bank account besides her annual visit. How much money will she have in her account after her 10th deposit? Okay. Now this is a strange one because of the way banks work. All right. This sounds like it would be a partial sum, but it would be just an explicit because she's just depositing money and it's not adding itself up as it goes along every year. Okay. All right, so let's give you an idea of the sequence. If she has $100 the first time, and she puts $100 in, and then she has $200, okay, in the account. All right, then the next year she has $200 in the account, so she puts another $200, so she's at $400. All right, I think hopefully you can see where this is going. It's a geometric sequence. You're multiplying by 2 each time. So the reason why it's not it's not a partial sum problem is because you don't take the 400 plus the 200 you had the year before plus the 100 you had the year you started and add them all together to give you $700. You only have $400 in your account. Okay, so that's going to be an explicit term. We're going to find the 10th deposit. Okay, so you could technically just keep multiplying out and find the 10 terms, or you could use the explicit formula. Start out with 100, multiply it by 2. 10 minus 1. So we have 2 to the 9th times 100 gives you 51200. All right. So the next section, we have some word problems, and you want to find the sequence, or the formula that goes along with them. So let's look at number 12. Mr. Wallach has $40 for lunch money at the cafeteria. Every day he spends $2. How much does he have on the 17th day? So this is asking for the 17th day, not overall, which is an explicit formula. And since he's spending $2 every day, you're looking for an algebraic explicit formula, which is going to be B. Oops. For number 13, algebra is starting to study for the ACT. He studies for 40 minutes the first day. Each day he adds 2 minutes to his total studying time from the previous day. After 17 days of studying, how many total minutes has he studied? The key is the total. He's also adding 2 minutes, which means he's an algebraic partial sum formula, which would be D. Mr. Panther's preparing for this year's competition. To do so, he does push-ups for 17 straight days. First day, he does 40 push-ups. If every day he does twice as many push-ups as the day before, how many total push-ups would he have done during that time? Again, the key is the total, which means it's a partial sum. He's doing twice the number of push-ups, which means it's a partial sum for a geometric, which would be A. And lastly, although it's obvious which one this should be, let's read the question anyway. Mathematics is training for a marathon. He consults Mr. Brady. Oh, thank you. For a radical new training plan. The plan tells him to run 40 yards on day one. For every following day, he needs to run twice as far as the previous day. If he keeps this up, how far will he run on the 17th day? Again, we're looking for day 17. We're not looking for a total. So that would be an explicit for a geometric because we're running twice as much, which would be C. Oops. And there we go. Okay. For an arithmetic sequence, u sub 4 is 10, u sub 7 is 25. What is u sub 25? Okay. Well, there's a lot of ways you can do this. Okay. Excuse me. First thing we should probably do is figure out what kind of sequence this is. Oh, it's an arithmetic sequence. Sorry. That we should know it. Okay. To figure out what the common difference is going to be, we're going to take 25 minus 10 and 7 minus 4. We got the 7 and the 4 from here, which gives us 15 over 3. Okay, which gives us a grand total of 5. So, based on this, what we can do is we can go down to find the first term. So u sub 4 is 10, that means 3 is 5, 2 is 0, 1 is negative 5, and that's it. So u sub 1 would be negative 5. Your common difference is 5. And we're looking for 25. So you can use the explicit formula. So we have negative 5 plus 5 times 25 minus 1. So we got 24 times 5 minus 5 would be 115. All right. Oh, that shouldn't say 5 through 10. Ignore that. All right, we want to find out if these are functions, yes or not. No. So the first one, all the x's have their own distinct y's. So every x has its own y. So that would be a yes. For the next one, this would be a no because 5 has 2 y's. So this one can only have one y per number and has both negative 1 and positive 5. So that's a no. The next one, this is a yes because although the 4 is seeing 3, 4 is seeing 3 again, and that's fine because it's the same number. Right, the next one, each x has its own y. That is a yes. This is a weird one because the line's a little bit off, but I'm going to go a no. I'm going to say that's supposed to be negative 7 on 4. Or we're missing a number in there someplace, but I'm saying no. And then 22, this is going to be a no because 3 has 0 and 1, so each x does not have its own y. So again, for these problems, we're looking at functions of yes or no. Each x can only have one y. If it doesn't, it would be the x does not have just one y, it has more. So there's your explanation. All right, domain and range. Domain, we're looking for the x values that exist in the graph. So it starts over here on the left at -9, and it should be a parentheses because it's an open circle, and ends over here at +6. It should be a bracket because it's a closed circle. For the range, we're looking for the lowest number here, which is -6. Because it's on a solid line, it is a bracket, and the highest part of the graph is up here at +6, and it is in parentheses because it's on a parentheses, because it's open circle. Look at it. All right. Next, f of -6. So here's -6 on the x-axis. What is this point? It is 0. All right, for f of 5, we're looking at 5 on the x-axis, which is right here. We're looking for the graph at 5, which is down here at -1. The domain starts on the left there, which is at -7, which is a parentheses because it's on an open circle, goes to the right to positive 8. It's a bracket because it's on a closed circle. For the range, we start at the bottom, which is going to be down here at positive 1 with the parentheses because it's an open circle. It's going to go up to, I'm going to say it's here. It's a little bit off on the graph, but we're going to say it's 9 with a bracket because it's a closed circle. G of negative 5. Negative 5 is there on the graph. So we're looking for the graph point for the y value, which is going to be 2. And G at 0, oh, this graph's been moved a little bit. G of 0 is right here. We're looking for this. Just for the sake of argument, I'm going to put 4.5. All right. On the test, the graphs will be a little bit cleaner. This graph got moved because sometimes it's hard to put those lines on these graphs. All right, try another one. Domain from left to right. We start off at negative 7 with a parentheses. Go over here to positive 8 with a bracket. That's an ugly bracket. That's better. For the range, the lowest part is down here. We're going to make that negative 4 bracket. And it's going to go up to the top, which is going to be 8. And since it's a solid line, it is also a bracket. F of 4, so we're looking at the x-axis at 4, moving up to the graph, we're going to say that is 3. And at negative 1, the graph is starting here. We're going to go up to the top of the graph, which is going to be right there, which is going to be at 8. There we go. Last one. Domain goes over to here, which is going to be at negative 9. It is a parentheses to positive 9 on the other side, also parentheses. The range, the lowest point of the graph is down here at negative 7. Because it's on a solid line, this is a bracket. It goes all the way up to the top at 10 with the parentheses because it's an open circle. All right, G of 8. There's 8 moving up. It's going to be right there at 5. And G of negative 7 is right here at 0. And that is the review for the test. All right, hopefully this helped, and good luck.